Hello and good morning everyone. I welcome you all to India's largest learning platform, Unacademy. And I welcome you all to the GATE Conqueror channel. The new series, Antennas, Concepts Through Question series. In part 1, we have discussed about some essential theoretical concepts that are required, or the fundamental things that are required for understanding. In part 2, we'll start up with questions. Yeah. Anything you need to ask, you can ask dear. Before we start the class, let me introduce myself. I'm G Reddy. I have 15 plus years of experience in teaching, guiding and mentoring GATE and ESE aspirants. I work as motivational speaker pan-India from the past 12 years, expert in field theory and communications. This is the official link where you can join us on Telegram. The advantage of joining us on Telegram is you get a personal level assistance from all the faculties of the GATE Conqueror channel. And the good news for all the GATE Conqueror followers is 4 more educators are going to add to our channel on 10th of April, 8 p.m. Just stay tuned to our channel. We are going to introduce, as I told you in my previous sessions also, that more educators are going to join us, and there is a launch of 4 new educators to our channel, and we are ready to, and we are geared up to complete GATE and ESE syllabi comprehensively. So get prepared for GATE 2023 and ESE 2023 with GATE Conqueror channel. Unacademy offers 2 paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the FaceTime of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you will have all these features. Along with that, you have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts within 24 hours, preparatory study material, that is specialized notes and practice sets, personalized test analysis, study booster sessions or workshops, and customized study planner monitored by the personal coach. All that in Iconic, dear. And whether you go for Plus subscription or Iconic subscription, I recommend you to go for a no-cost EMI. The total cost is divided by number of months without any extra charge. You can use our code KNR10 for the same deal. By using KNR10, you get extra 10% off and also complete team support. The Iconic subscription, you get 1:1 live mentoring, increasing your chance of getting a top rank. And this April 10, 11 a.m. dear, this April 10, 11 a.m. you have a combat for GATE and ESE aspirants. Separate paper will be designed for mechanical, civil, electrical, ECE and CSIT. 20 questions will be asked, 60 minutes will be given, and those who secure a rank from 1 to 3, we are ready to give away 100% scholarship. Rank 4 to 10, we are ready to give away 75% scholarship. 11 to 50 we are ready to give away 50% scholarship, and 51 to 100 we are ready to give away 25% scholarship. And you can enroll using our code KNR10. There is no enrollment fee here. So showcase your talent, showcase your knowledge, and try to top the combat and try to get a free subscription for your own. We have the best study material for GATE and ESE here. That's the good news that you have. Where you have the notes that has been designed by top educators. We have comprehensive syllabus coverage, solved examples with which will build up your problem solving skills, chapter wise practice questions, and you can access anywhere and anytime, of course. And it is, the good thing is, it is available for both plus and iconic learners. So you can enroll yourself here by using the code KNR10 to get extra 10% off. And a hearty congratulations to all our GATE toppers for GATE 2022. And out of the 10 toppers, you can see we secured 3 All India rank 1s. This speaks volumes about the quality of education that we provide at Unacademy platform. And April 7th is the last date here where you need to take the subscription. After April 7, from April 8 onwards, you'll have a 10% hike in the price. So try to beat the price by using our code KNR10. You get an extra 10% off, and also you'll beat this particular 10% off. You'll beat this 10% price and you get an extra 10% off. So overall you get a 20% benefit. So try to hurry up and enroll yourself here. Try to get in touch with our counselor if you have any doubt in your preparation journey, subscriptions or latest offers. This is the number for the same. This Unacademy Ask a Doubt feature where you can ask unlimited number of doubts. It is available on app and website. You can ask 3 doubts at a time, and you can also get the preferred solution in your preferred language. It's also very easy to ask your doubt. Just click, crop and submit. This is special class features which includes interactive live classes, polls for the learners, raise hand option. You never miss a class when the notification is on. You can download the lecture notes then and there, and you can access anytime and anywhere. Introducing community here, when you never miss any update from your favorite educator. You can get the session notes and practice material, and also you can share the feedback directly with educators via polls. These are the new batches which are started on March 30. That is Resilience batch for GATE 2023 for Electrical Explained Bilingual. Resilience batch for GATE 2023 for ECE Explained Bilingual started on March 30. Evolve GATE 2023 for Electrical Explained Bilingual. Evolve GATE 2023 started on April 6th for Electrical Explained Bilingual. Ascend GATE 2024 for Electrical Explained Bilingual. Ascend GATE 2024 for Electrical Explained Bilingual and started on April 6th here. These are all the new batches. You can join any of this batch and you can use our code KNR10 to have an extra 10% off and complete team support here. So we are into antennas concept through question series. We'll try to discuss some questions, and we also try to learn some concepts through discussion of questions. And on antennas, we already covered a series called sorry dear. On antennas, we had already covered a series called Antennas Maha Marathon series, with having a playlist of 18 videos and 38 hours of content. This Antennas Maha Marathon series In this series, we have discussed in-depth analysis of this 7 sister antennas, antenna measurements, and wave propagation suitable for both GATE and ESE. The syllabi which is suitable for both GATE and ESE. And in this particular class or in this particular series, we'll try to discuss some questions and also we'll discuss some concepts. Any doubt you can ask dear. Yeah. So let us discuss some questions. First question. For an antenna at R is equal to dash meter, at R is equal to dash meter, induction fields are equal to radiating fields. At R is dash, induction fields are equal to radiating fields. Please try to answer here. At R is dash meter, induction fields are equal to radiating fields. As I told you already, we try to learn some concept through each question here. You try to give me the answer, we'll also have a discussion on this. What is the answer here? See, very nearer to the antenna, if you take an antenna, which is having a largest dimension D, capital D, very nearer to the antenna, with R value less than lambda by 6, induction fields will dominate. Induction fields means components having 1 by R cube, 1 by R square and higher order terms are all induction fields, they will dominate. R is greater than lambda by 6, radiating fields will dominate. Radiating fields are components having 1 by R term. They will dominate. And at this point, R is equal to lambda by 6. Both induction fields will be equal to radiation fields. So what's the question? For an antenna at R is equal to dash meter, induction fields are equal to radiating fields. R is equal to lambda by 6, induction fields are equal to radiating fields. R less than lambda by 6, induction fields will dominate. R greater than lambda by 6, radiating fields will dominate. Induction fields are those which are having the terms 1 by R square, 1 by R cube and so on. Radiating fields are those which are having the terms 1 by R. Clear? Next question. In a circle we have dash radians. In a circle, we have dash radians. In a circle, we have dash radians. What's the answer? In a circle, we have dash radians. The circle, let this be a circle of radius r. The circumference of the circle is 2 pi r, and radian is defined as the measure of a plane angle with its vertex at the center of a circle of radius r subtended by an arc of length r will make 1 radian, and you know circumference is 2 pi r. Each r will make 1 radian. So in a circle, how many radians you have? You have 2 pi radians. Each r is making 1 radian. From this concept we got that in a circle we have 2 pi radian, but we know that in circle we have 360 degrees. From this we got 2 pi is equal to 360. And from this pi is 180. 1 radian is 180 by pi degrees. 1 radian is 57.3 degrees. From this we got this conversion here. In a circle we have dash radians 2 pi. Yes, Karna, correct. See here, this depicts the concept of radian. This is a circle of radius r. It is vertex at the center of the circle of radius r, subtended by an arc of length r. It is making 1 radian. It is making 1 radian. Explained here also. See here, this is 1 radian. It is subtended by length of r. Okay. I'll depict you the radian concept here. The radian concept is an arc of length r. You have drawn with radius r, you have drawn a circle. the same r he has taken as arc, and with that arc gets subtended an angle which is making 1 radian. One more r, 1 more radian, 2 radians, 1 more r, 1 more radian, and 0.14 is left out, that is 3.14 radian, which is pi radian. Half of the circle is done, 1 more half, 2 pi radian. Clear? In a sphere, we have dashed radian. In a sphere, we have dashed radian. In a sphere, we have dashed radian. Consider a sphere of radius r. Steradian is defined as the measure of solid angle with its vertex at the center of a sphere of radius r subtended by an area which is equal to area of a square of each side r. That means area of a square of each side r is, area is r square area. Each r square is subtending 1 steradian. Subtending 1 steradian. In a sphere, we have area of a sphere is 4 pi r square. Therefore, in a sphere, we have 4 pi steradian. In a sphere, we have 4 pi steradian. The question, in a sphere, we have dash steradian. Option D is the answer. See here, this r square area is subtending 1 steradian. Area of the sphere is 4 pi r square. Therefore, we have 4 pi steradian. This diagram also shows you the same concept. You can see the solid angle. It's not a plane angle. This is solid angle subjected by solid areas. This circle having of radius r having circumference 2 pi r. In circle we have 2 pi radian. Each r gives you 1 radian, and a sphere 1 r square will give you 1 steradian. Total area is 4 pi r square. Therefore, we have 4 pi steradian. Steradian is equivalent to radian square 2 radian, radian by 2 and degrees. Steradian is equivalent to radian into radian, because each r square will subtend 1 steradian. Each r will subtend 1 radian. R square is r into r. Steradian known as radian square Option A is the answer. Yes, correct. FNBW. FNBW means beam width between Fresnels. What is a Fresnel, dear? Take a radiation pattern. Main lobe, side lobes, minor lobes and the back lobe. The region where there is no radiation is called null. One null is here, another is here, another is here, another here, another here, another here. All these are nulls. And a null that occurs between the main lobe, this is the main lobe or the major lobe, and the side lobe. Side lobe is a lobe which is in the same plane as that of the main lobe and is a minor lobe. It's called side lobe. Side lobe. And a null that occurs between the main lobe and a side lobe is called as Fresnel. So this is Fresnel and this is also Fresnel. The angle between these two Fresnels will give you beam area, which is given by FNBW, beam width between Fresnels. So what is the unit to measure FNBW? That's the question. Try out, dear. Yes, anyone? FNBW is a measure of plane angle. It is measured in degrees or radians. 1 and 3. Option B is the answer. Yes, correct. Half power beam width is measured in. If you consider the radiation pattern, this is the main lobe, the side lobes, minor lobes, this is the back lobe, and the null that occurs, a null is something that occurs between the region or occurs in the region where there is no radiation. This is a null. This is also a null. This is a null. This is also a null where there is no radiation. And a null that occurs between the main lobe and the side lobe. The main lobe. And this is side lobe. A null that occurs between the main lobe and the side lobe is called Fresnel. So this is one Fresnel, this is one more Fresnel. Angle between them, FNBW. The z-axis. If this point is R, angle here is theta, it is also theta. FNBW formula is 2 times of theta. provided during the measuring of this theta value the power must be 0 because it is in the null position. Power is 0. There is no power. There is no signal. If the power is 0, no, wrong, Karna, wrong. Okay. This is FNBW. And if you take a 3 dB point, if you take this point, here power is maximum, Pn of theta is 1. If you take a 3 dB down point, what is 3 dB down point? At every 3 dB down, what happens to power? For every 3 dB down, the power will become half. Pn of theta is 1 by 2. Pn of theta is 1 by 2. Now if you draw the tangent, this plane angle through which half of the power is going is called half power beam width. Now you tell me, half power beam width is a measure of plane angle or solid angle? Half power beam width is also a measure of plane angle. Here also 2 theta, but now power is 1 by 2. At this point the power is 1 by 2. Both are plane angles only. Plane angles are measured. This one dear, one. Plane angles are measured in degrees and radian. 1 and 3. Option B is the answer. Is that clear? Of course, but 2 and 4 is also not correct, no? 2 and 4 in what way it is correct, you tell me? You said C. 4 is steradian. Half power beam width in any case is not measured in steradian. Am I right? If you had selected C, that means you are going with option number 4. And option number 4 is not correct anyways. FNBW is equivalent to what? FNBW, beam width between Fresnels, is equal to 2 times of theta. Provided here Pn of theta is 0. Half power beam width formula is also 2 times of theta. Provided here Pn of theta is 1 by 2. How they are interrelated? FNBW is 2 times of half power beam width. Option B is the answer. FNBW, remember, is a measure of plane angle. Like you take a paper and draw an angle on that. That's a plane angle. It's not an angle subjected by solid objects. It's not a solid angle. Try to understand this. How are you, sir? So what you need to try to understand here is, they are basically plane angles. People get confused between plane angle and solid angle. Plane angles are basically those which are subtended by arcs or lengths. And solid angle is those which is subtended by a solid object. So here both FNBW and half power beamwidth, both are plane angles. The interrelation FNBW is 2 times of half power beamwidth. Students are awaiting your lunch, Shyam sir. Shyam sir has joined us in the chat box. We will truly rock the sessions, don't worry. Next, if half power beamwidth in E plane is 30 degrees and half power beamwidth in H plane is 40 degrees, beam area is, yes dear, what's the answer? What is the beam area? Beam area is a measure of solid angle, steradian. Steradian alternate unit is radian square. A degree square, which is nothing but square degrees. So 30 degrees into 40 degrees will become 1200 degrees into degrees, square degrees. The option D is the answer. Clear? An antenna has the largest dimension of the largest dimension of 1 meter. Operating wavelength 1 meter. Then Fresnel region is, calculate. Fresnel region is Fresnel region is Fresnel region is this is the antenna. The region with radius R1. With R1 is 0.62 into under root of dq by lambda. With d is the largest dimension of the antenna, lambda is the wavelength. This region is called reactive near field region. reactive near field region. And this region with radius R2 R2 is 2d square by lambda. It's called radiating near field region. This radiating near field region is also called as Fresnel region. Now, this is the Fresnel region. So just imagine, what are these? These are like spheres. This one sphere and this one more sphere. These are spheres. So out of like you take a football. Good evening, Bhaskar. Like you take a football and you try to place a cricket ball within it. Now if you try to carve out this cricket ball space from the football, the remaining space is the Fresnel region. Calculate. Calculate here. Yes, calculate. Anyone? Calculate and tell me the answer. Small logic is there, you need to understand. There's a football, within the football there is a cricket ball. That cricket ball volume we should remove from the total volume. Football volume minus cricket ball volume will give you Fresnel region volume. Volume, not area, okay? What's the answer? First calculate the total volume. For reference you say football. 4 by 3 pi r cube volume of a sphere. R is, this R is R2, 2d square by lambda, 2. Largest dimension 1 meter. D square by lambda 1 meter. Luckily you got simple numbers here. 4 by 3 pi 2 cube. 32 pi by 3. How much it is? Calculate. No, wrong karna. Calculate. Don't do it in air. Calculate. Calculate here. Okay, calculate. (32 pi by 3). Why it is taking so much of time? 32 pi by 3. Volume of the football is 32 pi by 3. 32 by 3, 10.66 pi. This is total volume. Minus, you must remove this inner volume. Further calculate R1. 0.62 into under root of d cube, 1 cube by lambda 1. This is 0.62. The cricket ball. 4 by 3 pi r cube. 4 by 3 pi r is 0.62 whole cube. Calculate and tell me. How much is this? Calculate and tell me. Are you able to understand the logic? The total football volume minus cricket ball volume will give you the between space, which is the Fresnel region, okay? Four by 3 pi into 0.62 whole cube. How much it is? .62 whole cube into 4 by 3 pi cube. 4 by 3 into 0.62 whole cube if you do 0.3177 pi. Please verify. Please verify. So this volume minus this volume, 10.666 pi minus 0.3177 pi, 10.3489 pi. That's your answer. The option C is the answer here. Got it? Very important model. Is that clear? Next question. Identify the true statements. Radiation pattern of isotropic antenna is circle. Tell me, is the first statement true? Radiation pattern of isotropic antenna is circle. Is that true? What is the radiation pattern of isotropic antenna? Anyone? The radiation pattern of isotropic antenna, anyone? The radiation pattern of isotropic antenna is a sphere. An isotropic antenna is an ideal antenna or imaginary antenna which can radiate equally in all directions. Its radiation pattern is a sphere. It can radiate equally in all directions. And one radiator is required to cover a sphere. No. Radiates in all directions means how can it be circled here? If it radiates in all directions, it can't be circle, am I right? In circle, it is not radiating in all directions. It is not radiating upwards. It can radiate in all directions. Means it must be what? Sphere. Is that clear? Radiation pattern of isotropic antenna. Yes, good. Is a sphere. So what's the first statement? Radiation pattern of isotropic antenna is a circle. False. Radiation pattern of isotropic antenna is a sphere. True. Directivity of isotropic antenna is 1. Is this true? Third statement. Anyone? Directivity of isotropic antenna is 1. Is this true? Is that statement true? Directivity of isotropic antenna is 1. What does it mean? Directivity indicates. Can anyone tell me what does directivity indicates? Directivity indicates number of antennas required to cover a sphere. How many isotropic antennas are required to cover a sphere? If you place just one isotropic antenna, it will cover the complete sphere. And directivity is defined as the number of antennas required to cover a sphere. How many isotropic antennas are required to cover a sphere, dear? How many isotropic antennas are required to cover a sphere? How many isotropic antennas are required to cover a sphere? 1. That's why the directivity is 1. Got the logic? If you want to calculate directivity in decibel, formula 10 log directivity to base 10. 10 log 1 to base 10, log 1 0. 0 dB. 0 dB. Therefore, isotropic antenna is also called as 0 dB antenna. Yes, correct. Directivity of isotropic antenna is 1. Correct. Directivity of isotropic antenna is 0 dB. In terms of decibel, it is a 0 dB. It's also called as 0 dB antenna. Is also correct. 2, 3, 4. 2, 3, 4. Option B is the answer. Is that clear? Efficiency of an antenna. Efficiency of an antenna ranges from 0 to 1, ranges from 1 to infinity, equal to GP by GD, equal to GD by GP. Anyone? Can anyone answer? Efficiency of an antenna. efficiency of an antenna is defined as the ratio of power gain to directive gain. It can also be defined as radiated power to total input power. Efficiency cannot be more than 100%. Therefore, it ranges from 0 to 1. First statement is true, correct. It is also defined as radiated power by total input power. What does it mean? If you connect a source here, the total input power of 10 watt. Out of this 10 watt, 8 watts is radiated power, and last power is 2 watt. Then how can you define the total input power now? Total input power is equal to radiated power plus last power. 10 watt is equal to 8 watt plus 2 watt. Therefore, efficiency is defined as the ratio of power gain to directive gain, or it is equal to radiated power by total input power, where total input power is radiated power plus lost power. And radiated power is defined as I square R. It is defined as I square RR, where RR, not RRR, RR is the radiation resistance. RR is the radiation resistance. Radiation resistance is also defined as the useful resistance, across which the radiation is happening. I square RR by I square RR plus WL. Lost power is I square RL. RL is the lost power. Cancelling out I square, the formula is RR by RR plus RL. These are different formulas for efficiency. GP by GD, WR by WT, RR by RR plus RL. And its range is from 0 to 1. If 1 is correct, GP by GD is correct. Other formulas are also I am giving you. WR by WT is one formula. RR by RR plus RL is one formula. Please note down. 1 and 3 are the options. Option 1 and 3 are correct. Therefore, option A is the answer. Any doubts? On a two-way transmission line, you take a two-way transmission line. Let me consider the source. This is the source. Two-way transmission line. If you consider two-way transmission line, the power is fed like this, the voltage is fed like this. Current distribution, positive cycle, negative, positive, negative. Here, negative, positive, negative, positive, go on. It goes on. This is how the current distribution is happening. The equivalent circuit for this is the source, parallel wires, parallel wire transmission line. These two adjacent cycles are out of phase by 180. So I draw it like this. And at any point, current is out of phase by 180 at any given instant. Current is out of phase by 180 at any instant. And on a transmission line, adjacent half cycles are out of phase by 180. Now you see, current of two adjacent half cycles. Current of two adjacent half cycles are in phase. Are they in phase, dear? No. Current of two adjacent half cycles are out of phase by 180. Second option is current. Current at any instant of time on two wires are in phase. At any instant of time they are not in phase, but at any instant of time the current is out of phase by 180. 1 and 3 are wrong, 2 and 4 are correct. 2 and 4, option D is the answer. Yes, Karna, correct. Sometimes you are answering good, but sometimes you are getting so much of confusion. So try to keep your basics tight, dear. You have a very good chance to get a very good score. So this is how the things will work in concepts through question series, dear. We'll discuss some questions through which we also understand the concept. Is that clear? Any doubts you can ask. Any doubts? Okay then. Thank you all, dear. Have a great day.